Yeah, so we'll start out with our Globus keynote, as we always do, with, of course, our patriarch, Ian Foster, and our director of products, Rachna Ananthakrishnan, and I believe I did that correctly. So, yeah, so thank you. Thank you for coming, and take it away, Ian.
Thank you, Greg. So thanks very much, everyone, for being here, both those who are here in person and those online. If I'm a patriarch, this is not a patriarchy. I would say maybe Rachna should be called the matriarch. I don't know, but the way we run things in Globus is I'm officially at the university the faculty director, which means I talk to people and pontificate, and then Rachna sort of makes things, along with the others you'll meet, makes things actually work. So really, you'll hear more from her in a minute. So I'm just going to say a few words about what we're excited about at the moment, and then Rachna is going to talk some more about some of the new product features and other things that are going on. So the theme for our meeting this year is Beyond Data Management. And I will spend a few words explaining what we mean by that. So, of course, Globus started off as a service for moving data, then became a service for sharing data, and then for indexing data. And as Rachna will say more about, it's also now a service for performing computations. So we really do aspire in our Globus work to provide services for reliable, performance, secure management of all sorts of research flows, research processes, and I'll explain why we think that's so important. First of all, just a picture with some lovely networks on it. I was at the ESNet 6 launch earlier this year and gave a talk there. ESNet 6 is the Department of Energy network that links all the DOE labs and many other institutions. Now is getting up, beyond 100 gigabits per second. It's not, of course, the only high-speed research network, but it's one of the leading ones. And this, I mention it here just to emphasize the extent to which we are all now connected. Our research institutions are connected at ultra-high speeds, and more than that, with ultra-high reliability in most cases. And increasingly also we are reaching out beyond these high-speed backbones via things like 5G and soon 6G networking, even things like free space optics as being pioneered by various entrepreneurial companies. So we live in a highly integrated environment. What we need then is a highly integrated research infrastructure. That's a phrase that's been coined by people at DOE, but I think it captures well what we want to be able to do. So we want to be able to quickly tie together resources wherever they are and integrate them into computational and data fabrics for various purposes. We might want to use it to power scientific instruments by linking them to remote computing. So here's an example of one such application we've been working on with people at the SLAC Linear Accelerator Center. They need to be able to use machine learning models to filter data coming out of very high rate experiments. They can perform the periodic retraining that's required at the beamline, but it takes roughly 20 minutes, or via Globus and ESNet and other things, they can move that same retraining task to across the country where they can perform it in 30 seconds. So a speed up of roughly 30 times, and enabling a new mode of doing science in this case, without having to create a equivalent supercomputer at their beamline. One of actually now dozens of such examples that we're involved in realizing by linking experiments with computers, with storage systems across this now quasi-ubiquitous high-speed network fabric. Or we might be wanting to mine and compare climate model outputs from centers around the world. The Earth System Grid Federation, we said a bit about last year, we're now part of the team running this. linking sites worldwide that create these multi-petabyte climate simulation data sets, and that people then want to be able to analyze in order to understand the impact of climate change. One last example, this is a team out of Argonne and the University of Chicago that won a Gordon Bell Award this last year, combining real-time data feeds from field labs, showing information about new genomic sequences, for example, for COVID or RSV or other potential pathogens, combining that data with the results of simulations on supercomputers, machine learning models being used to predict the likely evolution of these genomic sequences to identify variants of concern that can then be looked for in the field before perhaps they become a major health problem. So I could go into many more examples, but from our perspective, these are just things that people we care about are trying to do that involve linking resources of all sorts, in essential regardless of their location. And we view our job as creating the machinery that allows you to then link those resources together in a way that is performant, secure, and reliable. And how do we do that? Well, really just three things, just three tricks in our, we first of all make it possible for people to act on resources regardless of where they're located and the details of how you access them. And these might be storage resources or now compute resources. We allow them to execute actions on those resources reliably. And then we provide sophisticated mechanisms for controlling who is able to perform those actions and when they can perform them, where they can perform them, and what actions they can perform. And we do those three things that we do are basically achieved via a combination of local agents deployed wherever you want to access resources, cloud-hosted managed research acceleration services, which is really, I think, the key innovation underpinning our Globus services, and then this Globus auth-based distributed authentication infrastructure. And I'll say just a few more words about each of these. So first thing we need to be able to do is act anywhere. So, if you're engaged in climate model analysis or building smart instruments, you want to be able to reach out and access any compute system or any storage system that is relevant to the work that you want to do. And of course, there are millions of such systems worldwide that you could be using. Our basic agent software that we provide, this is Globus Connect, as many of you are familiar with, or FunkX for computing. They're packaged so they can be deployed essentially anywhere with very little effort and then configured to allow controlled remote access. Now, being able to perform operations in different places with simple APIs is, of course, essential to effective distributed action, but we also need to be concerned about reliability. Just as we well know, computers fail, networks fail, all sorts of things fail. The key to success then is often to introduce a level of interaction and to provide cloud-hosted supervision services to which you make the request to do things. And those managed supervision services then make sure that they happen retry if they can't happen, and in the worst case, come back and tell you that something went wrong. And this is basically the Globus transfer service, the FunkX computation service, the flows service that you'll hear more about later. These are all things that run management logic on the Amazon cloud using its geographic replication and its sophisticated monitoring to achieve high reliability. And then they ensure that things happen in different places. And then finally, we need to be able to control who can act when and where. And of course, this is in principle, it's straightforward. In practice, it's quite complicated because, when I, as a scientist, say I want to run this pandemic surveillance application, I'm not going to be sitting there myself giving permission for each of my computational subtasks to run at each of the locations where computation may occur. Instead, I want to delegate that authority to a program acting on my behalf. And in fact, the key to the Globus security model is this notion of controlled delegation. So we have very sophisticated mechanisms for allowing an individual, a scientist, to grant to a program that then itself grants to Globus services the right to perform actions that may be required for their work to occur. And I've got a little animation which I'll just click through quickly. But this is the sort of thing that's happening. Hopefully you can see it. I'm the guy with the spoke, what are those, the wheels in my head, and I want to ask something to happen, a flow to execute. So I grant a consent to that flow to perform certain actions. The flow will then go ahead and register with an Globus auth server that will then at various points grant further authority to, say, the FuncX service to perform a remote computation. Other tokens flow back and forth, and ultimately a program runs on the remote computer that I have authorized to run, and Globus can track every aspect of that and ensure that only the right thing happens at the right time. So this is really, when you use Globus or Globus Transfer or FuncX or other services, you're not aware that this is going on, but there's some magical stuff happening there which allows us to perform these very large and complicated distributed computational structures without any security risk or having to be aware of the details. So that's Globus in three things. So local agents, managed supervision services, and delegation of authority. And those things together allow us to do some amazing things. So here's you've probably seen a slide like this before, but this is slightly updated. So this is what this is translated to in practice. We have more than 400,000 registered users, 55,000 active Globus transfer agents. I don't think we count Globus, the FuncX agents yet. 1,600 institutions running the Globus Connect servers. We're moving more than a petabyte of data per day, and you can watch that clicker out there go by. I'm very proud of that clicker, by the way. 55,000 active Globus Connect endpoints. And so what are all these endpoints? Where are these endpoints? Well, one thing, if you were at any research institution, there probably are quite a few of these endpoints there. Some institutions have one for their central storage system. Some will have dozens. Here's you can see read the fine print. This is the advanced photon source at Argonne, where basically every beamline has a Globus Connect endpoint. There are also FuncX endpoints at various points that are being used to provide access to computational resources. But these things occur worldwide. So I'm going to see if I can make this video play. I made this video for, oh, there it is. Who's seen this video before? I think a few of you have, but not too many. So thank you, yes, Fred. So I made this video. It's showing all transfers of more than, I think, 100 megabytes in size since Globus started, showing the transfer size on the y-axis and the distance that the transfer is moving on the x-axis. So if you think, very far apart transfers. And so this is, so obviously any transfers within the US will be mostly on the left-hand side, because you can't go more than 4,000 kilometers or so and still stay in the US. But there are transfers going all over the place around the world. There's a big gap there in the middle. Can you think what that is? It's the Atlantic Ocean, I think. I mean, there are very few places that count, i.e. places that have Globus endpoints that are exactly 5,000 kilometers apart. So what's that? Satellite, yes, right. Yeah, so there could be a satellite. Anyway, so it's just, if you watch this, you'll see the this starts mostly in the US and then spreads out, and now people are really using this infrastructure to connect, to perform global science that connects people regardless of location. And being from New Zealand, I was very interested in what was this the furthest distance there, which has turned out to be from Wellington to Madrid. As a kid, we grew up in New Zealand. New Zealand was always called the Antipodes, because we're on the opposite side of the world from England, which is what, where New Zealand sort of came from originally. And actually, this is an old map showing from, I think, a 1930s atlas, showing the Antipodes of New Zealand. So you can see how close Madrid and Wellington are to being on the opposite sides of the world. They projected Madrid and Wellington through. So Globus is used to move data almost from one side of the world to the other, just a few kilometers off. So we have a Globus team member in Wellington, so he's going to perhaps move up the coast a bit and do a transfer just from here. Sorry. Okay, how are we doing for time there? We're just about right. So anyway, so the key message is, we've built this amazing infrastructure for doing basically global science, for connecting resources regardless of location, where people are using this infrastructure for all sorts of things in all sorts of places. Now that we've added support for flows and computation, we're seeing really interesting new workloads, not just people moving data, but people performing real-time analysis of data from instruments. This is a set of flows associated with advanced photon source beamlines of different sorts, linking together different steps, probably with fine print that you can't read, but these are a mix of computational steps, data transfer steps, data cataloging and indexing steps, and other things. And then also introducing new workloads into the computers that we use to power these flows. This is creating much challenges and opportunities for places like the Argonne Leadership Computing Facility, which is hosting many of the computational tasks associated with these applications. So it's going to be exciting over the next year and beyond to see how these new flows start to make yet more exciting uses of these computers. So at this point, I think I'm going to hand over to Rachana, and she'll drill down into some details, I think. So thank you.
Thank you, Ian. It's hard to follow a talk with a fantastic video and talking about antipodes and everything. So I'm going to talk more around the platform itself and provide an update. Vas and I were noodling over, we every time talk about what the transition slide should be, and this time it's going to be the state of the Globus world. So thanks, Carl. Okay, I'm going to start with first a very high-level summary of the Globus capabilities. Ian already talked a lot about the impact and a really nice summary of key architecture elements, the hybrid architecture, the fine-grained security that we have, the idea of agents and such. So I'm going to start talking a little bit more in terms of the capabilities. And then second half of the talk, I'll present information about what we see as key product drivers and where we see things going in terms of future investments. So if you haven't heard this before, so the first one is the reliable managed transfer. So as Ian showed, extensively used, it's year number 11 for us, and still remains one of the most used product services in our suite, right? Then Globus provides data sharing. So this is collaborative data sharing, eliminating the need for local accounts, replication of data, just for you to be able to share with your collaborators, right? So something very unique, especially in the research space. The third one is unified data access. So this is providing a single API interface and a pane of glass for accessing heterogeneous storage systems. So whether you're looking at POSIX systems, or you're looking at object stores, what have you, being able to use the same API and the same service for users to access. Right? The Globus Search Service provides a data discovery solution. It is a scalable search, but the key aspect there from a research perspective is the security piece, the ability to be able to manage visibility. You can control visibility of the metadata elements. You can control visibility of specific, not just all of your metadata, but even specific elements of your metadata. And then finally, the reliable automation, right? This really brings all of these pieces together and allows the researchers to be able to leverage this at scale, essentially being able to do this at scale. This provides the management and reliability that you'd see with transfer, but for task orchestration. So you're able to define pipelines and manage that. So all of these we see as key capabilities that are being provided for research IT and leveraged by users today. It's really critical to look at how it is being used. Software as a service has been the case from the very beginning, and that has dramatically reduced the barrier to entry. So we still continue to see over 90–95% of the usage is just from a web browser using our web application, right? So no complicated installs and such. But we've also been a platform as a service from day one. So there's secure APIs that are available. So it is an extensible architecture. You can leverage these as building blocks and build things on top of it. And we're seeing a lot more adoption of that as well, right? So let's look at some of these facets, right? The first one is mobility. I think a while back, we talked about your data, where you need it, when you need it, right? So being able to get the data for research in the right place at the right time. And this is a growth chart. It's about all of the charts I have are 5 years worth of data here. And you see we have definitely a growth, but the interesting part of it is the number of new users. So you're really excited to see we continue to add new users to the platform while still maintaining a good chunk of people coming back to continue to use the platform itself, right? So that's one on the transfer piece. Okay, you can move your data. What's next? Being able to do it over and over again, right? How many of you here have cron jobs and have sync jobs that are running? So timers is the piece that lets you schedule transfers or have recurring transfer tasks or sync tasks. So you can also do synchronization tasks. And we have seen steady, actually really good growth on the transfer side, on the timer side, right? This is a snapshot. We have about 616 timers when somebody ran the metrics for me last week. So obviously it fluctuates the number of active timers. We're also seeing single users setting up multiple timers for various reasons, backups and sync jobs and so on. The inflection point that you see there in usage, that was when our web app added support for timers and made it as trivial as a few clicks, right? So you can come in and quickly schedule, add repeatedly, and that just completely changed the adoption curve on that feature. The last year, we've added support for it for the CLI. I know we have a smaller contingent, but a very dedicated contingent of CLI and SDK users. So we keep that updated as well. And we also added ability for you to filter sort timers. So we are starting to see where single users or single accounts are setting up multiple ones. So being able to manage that. I think we have one particular user, we don't know what they're doing, but they have about 200 timers set up for themselves. So still trying to figure out what the use case there is, right? So a couple of other highlights on the transfer service itself. Oops. Okay. So the first one here talks about idempotent active transfers. This really is important once we added the timer feature. What this ensures is that you will never have two transfers that are writing on the same file. So two active transfers that are touching the same collection, same paths will never run, right? For those of you who are API users or have used automation, you probably know we already have a once-only submission. So you can ensure that only one of your calls to the transfer service gets submitted. But this one goes one step further. Even if you end up submitting multiple ones, we ensure that we never write over the same destination, right? So you can see this is really valuable when you set up timers. So if your first timer is taking longer, if there are errors, we'll just ensure the data never gets corrupted, right? And the second one, much asked for, we have introduced both include and exclude filters on the transfer service. So you can do complex filters now to transfer just the files that you need to move. The web application added support for exclude, and the CLI has support for both those options, right? So these are just really small highlights. I have these highlights everywhere through my presentation. But I also want to mention it is really difficult to provide a summary of the kinds of features that get pushed out in a whole year in a 1-hour talk and make it meaningful. We have releases every week. Some part or the other of the product has a release, and releases go out every week. If you're not subscribed to our Globus Discuss list, I strongly encourage you to do that. Release notes are published on that with information on any feature that's going out, bug fixes and all of that. Okay, so that's moving data. So the next pillar here is collaboration, right? This is really unique to the research enterprise. This is not data that just sits in one place. Ian just showed you people are moving across the world. And a lot of this here comes down to being able to do data sharing, right? So this graph here is, again, 5 years worth of data showing growth in use of the data sharing feature in Globus to be able to make data available to your collaborators. Again, this feature is valuable. You're not replicating any data, and you're using your collaborators' credentials to share. So just with their institutional accounts, you're not creating new accounts for them. The blue there are Globus Connect version 4 deployments. The orange is version 5. And then the gray, the small one that you see there, are Globus Connect personal deployments. Many of them are people's laptops, but we also see Globus Connect Personal used at instrument facilities and places where they have Windows machines. A lot of the acquisition machines are Windows machines, and sharing is used because it supports automation, right? So that's the growth you're seeing on the Globus Connect Personal as well. So I had this slide prep before I talked to the IU team that had come here, but we talked some about the tension between allowing users to manage collaborative data access and the need for meeting all the IT regulations, the compliance, the security requirements, right? There's always this tension trying to figure out where to draw the boundaries. With Globus Connect Globus sharing that is supported over the years, thanks to a lot of the community, a lot of the feedback that we have received and various deployment scenarios we have seen, we have sufficient controls in place such that as an administrator or manager of this, you can place the guardrails within which a user can share, right? So you can allow them to share, not have the burden of having to be involved in every piece, but you can still set all the policies around that. And I sort of think of this as two sets of policies. What can you do before they share? What can you do after they have shared, right? So the first one is defining policy. So we have controls in place for you to be able to say who can share, what can they share, so what parts of the file system, to what level can they share, read, write access, open, what have you. And then we also have new features that was released recently for you to control who they can share with. So you can set domains that are allowed to access guest collections and such, right? So put all this together, there's enough of a boundary you can set. And then users within that are able to self-manage the data sharing piece. And then the second part is audit and management of what they've created, right? As an administrator, you have full access to all of the guest collections and shared endpoints. So you can see what has been created, who they are sharing with. You can see when it was last accessed. Not only that, you also can modify all of this, right? So putting these two things together, there is sufficient controls for you to be able to empower a user to manage their own collaboration and manage data sharing and take that out of your list as an administrator. Right? That takes me to the next one, compliance. So we've certainly seen a big uptick in the amount of protected data that is being handled, or even the compliance regulations that are being placed on data. So there's a shifting here, whether it's privacy standards or whether it's increased scrutiny over who's accessing data and such, right? I think it has been 5 years now since we released the high assurance tier, and we have seen steady adoption there. Again, this is, for those of you who are not familiar with it, the high assurance tier of Globus lets you manage protected data. So use all of the features that I just talked about, the transfer sharing with protected data. There are 2 tiers there. The high assurance tier lets you manage data that, for example, is CUI or PII data that requires some additional scrutiny. And then we have a tier where you can sign a BAA with the University of Chicago and use Globus for data that is HIPAA regulated, right? So the blue here are mapped collections. What that means is users are managing their and touching their own data. They have local accounts and they're moving and managing their own data. And the orange here, which is very interesting, is actually data sharing. So this is protected data sharing, and we continue to see growth in that as well, right? Collaborative access to protected data. And then the gray that you see there are Globus Connect Personal. So again, either it's laptops or machines or what have you, right? So we are, like I said, we are seeing a growth in the number of subscriptions that are at high assurance and BA levels, and campuses that are requiring more security documentation and such. So we have several operational security documentations that we make available. HECWAC, which I think is very common among the higher ed community as one of the pieces. We also make some of the system security plans and such documentation. And recently, actually, for the last year and a half now, some universities have had us use these third-party services. The two I have listed here are CyberGRX and Prevalent, where we have gone in and spent time putting all of our information in there. And that lets you export that information into various formats. So whatever your CISO's office wants, we can export these things out and make that available, right? Another aspect of compliance and what we see in contracts is accessibility. So we have a VPAC that describes that accessibility compliance piece. And you have probably heard me mention this in the previous keynotes. There has been a lot of concerted effort to get ourselves WCAG AA compliant, right? So the web application and such are there now. And I'm sure my team will remind me it's an ongoing process. We not only have done, it's not a one-time lift, but we've also thought about process and procedures to keep ourselves at that level as well. And then finally, we have a lot of European use as well. And so we do contracts that are GDPR compliant. And we're also starting to see a lot of some of the contracts, I wouldn't say a lot, that are also looking at privacy laws here in the US that are about equivalent. So complying with that and contractual obligations there. So that's on the compliance side. So given the data access, the data sharing piece, the protected data access and things, as Ian mentioned, you might on your campus definitely see more than, you might at least see one Globus deployment, but often we see a wider deployment set, right? So here's one example. We did a user story with University of California, San Diego. Across campus, there are many Globus endpoints. They're running at storage systems that are connected, whether it's running at departments, their research computing center. But the interesting thing about this user study is they're also using it more ways than sort of coming through our web application. So they have portals that are integrated in and are using that for data movement. Their secure enclave, I think it's called Sherlock at UCSD, uses the high assurance Globus tier for protected data management. They have cloud connectors, so the researchers can access that as well. And then one of the interesting things we worked with them and a few others is researchers in the field. So being able to use a mobile device and upload data via Globus, right? So this came up, research in the field who are using iPads or phones and taking pictures and wanting to move that via Globus. And this not only leverages the HTTPS upload and download that we have in GCS, but also we have had last few years of investment in making our web application responsive. So it can go from your laptop screen all the way to a browser and still provide users a good user experience, right? So it's something really cool to see. And I know we have had a few other, this is not just for this campus, we've had a few others talk to us about wanting to use this and going directly from their photo library to their RCC center, right? And much as I talk about this being cross-campus, Ian talks about it being global, definitely multidisciplinary, right? So you're connecting your people from various disciplines and various domains using this. On our marketing side, we have a bunch of user stories that Susan helps put together, and they're categorized by various domains and has some wealth of information on how they are using the platform and how they're leveraging this platform for these various domains. Just talking about connected. So all of this is possible because of those 16,000, 40,000, 16,000 shared endpoints and 40,000 deployments that Ian showed in his first picture, right? So this shows you Globus Connect server deployments. So these are multi-user deployments, not the personal laptop ones. And these are active ones. So we are only counting the ones at least some data was moved. And again, it's a 5-year plot. Everything in blue here is Globus Connect version 4, and everything in orange is version 5, right? Version 5 has been around for a few years now. If you are new to it, that's the version that provides the HTTPS access, has access to several premium connectors. All of the protected data management is through that on that version, and also has OAuth-based security rather than user certificates. And that significantly shifts how you can programmatically leverage data access, right? Makes it a lot more easy for you to integrate in there. Version 4 to version 5 migration, we've been beating this drum for a year, and I'm going to continue to do that. Please migrate your version 4 deployments and move to version 5. Migration tools are available for all deployments. So whether you have premium connectors, whether you're running ones with sharing enabled or not, all deployments can be migrated. The migration tools preserve all the configuration for you. We are striving to make this such that no user intervention is required. So your users shouldn't have to do anything at all. The administrator runs the migration tool, and then you get a version 5 deployment. It preserves your endpoint UUID as well, if you wanted to. So all of that. There is some downtime involved in the transition. It varies depending on whether you're running a multi-DTN endpoint or a single DTN endpoint. And I'll happily make a plug for the deep dive that is available tomorrow. So tomorrow, towards the end of the conference, most of the Globus team will be available where we had lunch. Feel free to go talk to them. They can help you with this or answer questions on your specific migration requirements. We are deprecating version 4 on July 31st. I know maybe not all of you are excited. The Globus team is very excited. So we are deprecating it, and the plan is to discontinue it end of this year, right? So please go ahead and plan for your migration. It is really not that difficult. Bridget can tell you stories about some of the really large deployments that have successfully migrated. So it's not that difficult to migrate, and you will get a lot of additional functionality as well as you move ahead. So a couple of Globus Connect highlights here, just like I did with transfer. So if you are running version 5, we use port 443 there for control channel. That remains the default port, but now you have the choice. It's configurable, and you can have the control channel be put on a different port if you would like. There were some deployments where the institutions were having a hard time getting security clearance for using 443 for control channel. So now it's configurable, and you can change that. A lot of work has gone in for automating the deployment itself. You heard a little bit of it today when Greg presented in the morning. So there is automatic registration and such. So you can certainly automate most of your deployments. And I also learned very recently that we are using our own containerization support for all of our testing. So it's out there. You're also welcome to use it. A lot of work has gone into making HTTPS more robust with reply codes and such. Again, the programmatic integration. So if you're sitting in a Jupyter notebook and you want to do a HTTPS pull, or you're building a portal and you want to do a preview, you should be able to pull your data out, right? And in progress is IPv6 support. So this is something many of you have asked for. I know for federal agencies, there are deadlines towards this as well. So we are working on this. This is everything for us, from all of our hosted services, the APIs that you contact, all the managed services moving to supporting dual mode, to updating all of our deployments, deployable software, GCS, Globus Connect Personal, Globus Connect Server, and looking at it from the perspective of working where it can work in dual stack, single stack, and so on. It is not as trivial as it seems as I'm standing up here and saying it, but we are actively working on it. And over the next, and I know I've already been asked or support tickets a deadline for a timeline for this. We don't have a specific timeline, but over the next quarter, you should start seeing product updates and announcements come out as we move these things over to dual stack, right? Connectors. So this is another big area where we are seeing growth. A lot of people are adopting, well, first it was Google Drive, it was Box, now it's a mix of those things. But we also have connectors to other tape archives and OneDrive and such. So we are certainly seeing an uptick in usage. And there's heavy investment that goes on this. So there's the initial building of the connector, but there's a lot of cat and feed that happens to make sure this continues to work as those products evolve, that we are also building with that, right? So for Box, we added user authentication via OAuth 2. If you've deployed Box with Globus, you know that we support enterprise credentials usage. But in this case, now a user can come in with this option and log in with their institutional credentials, and they can access their Box drive. So we added that as well. Requester pays option with S3. This is something that a few campuses have asked for, allowing the requester to pay for it rather than the person who created it. And then some OneDrive enhancements to be able to support increased upload size, right? So all that is over the last year. Coming soon is Dropbox. We have had several campuses ask for it, several institutions ask for it. I think some of them are using it even for protected data. So when this is some work that will get started pretty soon here, and over the next, potentially sometime later this year, a couple of quarters, you should see some Dropbox connector available. When it is, it'll be available on under the high assurance tier as well. So if you're using it for protected data, you can use that. Okay. So that's on the data side. Now moving on to automation. So for many of the examples Ian showed this morning, the impact examples, the scales at which people are working, whether it's the data volumes or how quickly they need to turn results around, all of this is powered through automation, right? You have to be able to do this at scale and fully automate it. The flow service in Globus is what provides the managed automation, and we have seen a steady growth in there. The chart on the left is the total number of flows users, just number of users who are actually using the service itself. The right-hand side one is the runs, how many executions. So you have flows that are deployed and users, or through automation, you can trigger this, right? So one example could be an instrument, data is coming out of an instrument. Once a data set is written, call the flow. So it automatically triggers and that creates a run. So you can see that is pretty spiky. So we probably can look up these dates and I can tell you APS experiments that ran, or somebody essentially doing a particular experiment that is causing data coming in and they're processing it very quickly. And that's causing all the spikes in that graph, right? So I have a few minutes here just to talk a little bit about flows. It's a relatively new service. The flow service, Ian mentioned this as well. It's a managed service for automation. It provides reliable managed automation. As a user, you are able to define a task pipeline and say this, where each step in the task can be any action. And the action can be Globus services. So you could be doing transfer, you could be ingesting to our search service, you could be setting permissions. But the action infrastructure is also an open API. So it's an extensible API. So you can call other services as well, right? You can write action providers to invoke other services. So if you have your own domain-specific service, you can do that. So you define a flow, and then each step in the flow is an action, and you deploy that. The Globus service then manages all the runs. So it provides you the reliability, security negotiation for being able to invoke all these actions, monitoring, management of that, and all those pieces, right? Now, the security infrastructure that Ian talked about, this fine-grained delegation and Globus Auth is a huge part of how we have built this. And it is set up in such a way that these actions can occur anywhere, right? So again, the hybrid model, the flow is managed by us, but what it is running can run anywhere. It could be at your institution, it could be at your cloud, it could be an external service. For example, we have an action provider that calls a data site to get an object identifier. So you could do all of those. We recently added, or in the last year, I don't remember exactly when, we added the ability for you to deploy flows from the Globus web application. So you write your definition that describes what you want the flow to do. That's the flow definition there. Then you can also add input schema that tells it what input is needed for the flow to run. And that is used to be able to generate dynamic forms. If somebody wants to run it from the web application, it generates these dynamic forms. It's really neat. You're going to hear a lot more about it from Vas tomorrow. We have an 1.5 or 2-hour tutorial that covers this in good detail. And for those of you using flows today, we've also added further enhancements in the web app for you to be able to manage runs. Like I said, some of these runs, if you looked at that graph, one experiment run could generate thousands of runs of the flow. So you're now sorting and managing and troubleshooting those. So being able to allow people the ability to manage all of those and look at the flow logs and events and such was all added in there. In addition to Vas's tutorial tomorrow, we also have several presenters through the conference later today and then tomorrow morning who are going to talk about how flows are being used at their institution, right? So it's really good. Some of them are using it from an instrument facility perspective and some are otherwise, but really interesting talks lined up on that as well. So what do we want to do on the automation piece? So we certainly want to add some more action providers. So we have several pieces of the Globus functionality that can be used as a part of flows. We're planning to add other pieces as well. The piece that I have here was really deploying flows from the web app. So you already write the flow definition somewhere, and then you can use the web app to deploy it. The piece we are working on and want to add to the web app is the ability for you to build the flows, make it easier for you to build it, right? And this is everything from you being able to discover what action providers are available there, to being able to create drafts of these flows and maintain them, test run them without having to deploy them, and code snippets. So we're working through lots of different ways of trying to make it easier and simplify how you build these flows. The timer service and the flow service are next in line to be added to our high assurance tier in that order. Yes, in that order of priority. So first timers will get added, and then we'll add flows as well, right? So ultimately, the vision here is that everything that we're doing, any services we offer, we want to add it in, but it usually comes out in the standard tier and then gets added in. And then the last one we have is trigger service. A lot of the examples that you're going to hear from, especially instrument facilities, when you hear the talks and even in Vas's tutorial, you will hear about how these flows are automatically triggered. So some condition is met, and then you call the flow. A lot of that is being done on the client side today. So at the acquisition machine, they're watching for a file of a particular type, and it appears, they're calling a flow to process it, right? So we're looking at trying to make this a hosted service. So you can stream the events to us, provide a condition, and that triggers the flow, right? Same thing that we did with timers. You were using cron. We try to move it up and make your life simple. We're trying to do the same thing for the trigger piece, right? What am I doing on time? Okay. So the last product piece, the most critical piece that I want to talk a little bit about is this notion of connected ecosystem, right? So I talk a lot about these different capabilities within Globus and using it in that context. But one of the really nice things about the way this has been built, and especially the security infrastructure, it allows you to build applications on top of it, customized applications on top of it, and build out that research ecosystem. This graph here shows you registered applications in Globus. So this is anybody building a science gateway portal, or even application code. I think at APS, one Beamline has a data management application that integrates into Globus for moving data. So any such application that they build, all of these things are registered so they can leverage our Globus security ecosystem. And you can see there's a pretty steady increase in those applications, right? So we are seeing more and more people not only using Globus, using our web application, or even but also building out more custom applications to leverage the infrastructure. And Globus Auth, which Ian talked about, is a fundamental layer that not only drives security for all of our pieces, but also provides the required security glue for allowing other applications to integrate in. Josh showed this in his presentation this morning, but we have tried to simplify. First of all, we have, if you've used developers.globus.org, all of the infrastructure for registering, managing your applications has been pulled into the Globus web app. It allows you to register all different kinds of applications that you build and manage those registrations. So all of this has been moved in. And if you're a longtime Globus user and you don't like when Sheets gets moved, we have renamed accounts to be settings. has the exact same thing. It just has a new tab. So it's just called settings right now. All the applications are managed in the context of a project. And we did that to be able to allow administration and management of these applications, right? So you can have a group of people administering it. And we actually added the ability to have a group manage a project, not just users. I think this is something that we got feedback on as well. And you can, of course, manage all of the application itself. You can rotate client secrets on it, manage redirect URLs, who's allowed to do all of this in pieces, right? So everything has been moved into the web app itself. And again, pushing towards making it easier and simpler for people who are trying to build out these pieces. I'm going to give a couple of examples here. The first one is Tapas. This is a service out of TAC. Probably Dan is going to talk about it this afternoon as well. And this provides a interface to be able to manage a lot of the scientific applications, so the job management and data. And Tapas, we worked with Joe Stubbs and his team. They integrated in Globus Transfer as a way of moving data within there, right? And this is a classic portal or a gateway integration method. And the win for them is a single API. So you end up getting all these thousands of endpoints where Globus is being run, so they can use that for moving data. And also, interestingly, data from different types of storage. So it's not just POSIX, whether it's S3, Google Drive, you could use all of that as well, right? So they use Globus Auth for token management there, and then they've added calls to be able to use Globus within Tapas. The second one I'll highlight here is service accounts. So one of the classes, so we talk about applications that are being used. There are these portals and gateways which act on behalf of another user. We also have a need for what are used for automation. So things are not tied to a particular user, right? Service account is something that you register with Globus. You end up getting a first-class identity for that account. We call them client identities. And they have a secret. The secret can be rotated, can be managed by having multiple admins manage it and so on, right? This example here is an APS Beamline that is using a lot of the Globus platform pieces. So it uses search and flows. But the key part here is they have eliminated the need for things to be tied to a particular user's account and their allocation, right? So they have registered a service account and used that to fully automate end-to-end all the way through even to the compute piece, right? And some of the flows that they run essentially end up populating a search index. So you get this really nice portal interface for a user to go browse and get their data. But again, being able to make it fully automated is allowed because of the service accounts. I'm going to mention one more project that uses a lot of the Globus platform and then quickly pivot through to some of the future pieces. So Ian mentioned the Earth System Grid Federation project. We heard about it at last year's, the PI was here at Globusworld last year. So those of you who are new to the project, this essentially acts as a repository and a data access method for climate model data. And much of this infrastructure has been used to inform IPCC reports on climate change and such. This is a new version of the project that started last year, and our professional services team is heavily engaged in building out the new version of this, of the whole data management infrastructure. It's a global collaboration, right? And in the new version, we are using a lot of the platform pieces. So Globus transfer and sharing for providing data access, embargo data access, and secure data access. Using flows, we are looking at a lot of the publication tooling that they had that is being used today is very much user logging onto a machine, running a bunch of scripts, and we are pulling all that, build out Globus flows to fully automate that, not only to make it simpler management-wise and reproducibility, but also to make it accessible. So a user can now publish from just a web interface or the ASGF portal, right? And then lastly, the Globus search index. So the project is looking at hosting a few central repositories of all of this data that people can come and search. This is one of the larger indices that we have done. And the professional services team worked on ingesting all of the climate data sets. About 7 petabytes of data was moved to Oak Ridge at Argonne, and about 5 petabytes of that is CMIP 6. So that was harvested in, and we have an index which where you can search about 5.5 million data sets and over 20 million climate files there using Globus Search Index. So this is still a project in the works. Our professional services team is deeply engaged. So a lot of the other examples I gave you, other people building things, but we also have a fabulous team that can work with you if you're interested in building any of this, or you would like some help in consulting on those things and building out some of this infrastructure. Right? So the last one, I cannot talk platform without talking SDK and then some CLI. So I think, again, this was mentioned this morning as well. The Python SDK is heavily used both internally by whatever products that we build, but also by external users in building out these pieces. We continue to invest there. As new APIs come out, we add support in the SDK and then build out support in the Globus CLI as well. Right? So the idea is to try to add as much, add the same functionality you could do from the web app. Okay, now on to the new announcement, although Ian talked about it, so it's never as much of a reveal as it should be. So, so we are adding a new capability to the Globus platform, which is managed remote execution. Right? Yes, drum roll. For those of you who have followed Globus for over 20 years, you might remember that Globus did both data. We actually had 4 pillars. We had data, we had remote execution, we had information services, which we have as search today, and then we had security, grid security pieces, which we have today, right? So this kind of completes very poetic, bringing back our compute piece, right? So Globus Compute is the service that provides managed remote execution. It essentially provides reliable, secure function execution. And again, it's very hard for me to describe this without drawing parallels to transfer. So it brings very much the same reliability management aspects that transfer brings to data movement to remote execution. So you should be able to go from using the service, you'll be able to go from running on your laptops and testing things to going to your HPC cluster or your supercomputing center or a cloud resource, all without having to start from scratch, right? So being able to leverage all this heterogeneous resources, and it provides all the necessary abstraction, different schedulers and such, all of the necessary abstractions are provided. And the management layer, the Globus Compute itself, provides all of the monitoring, management, and coordination that is needed for using these heterogeneous services. For those of you who know the FunkX project, this is the FunkX project being added, FunkX project and the services being added to the Globus platform. The project is it's an NSF-funded project, and that's how the functionality was built out. Adding it to the Globus platform allows us to offer it to a broader range of users, but also it was a key part of the sustainability plan for the service itself, right? We also really loved the logo. There was a lot of discussion about not using the logo, but this is the new compute logo, and we decided to add a pop of color. So the compute agent is going to be orange. Everything else is blue in our ecosystem, but a nod to the fantastic FunkX logo. So thanks to the very talented Vitas there. So the compute model follows the same principles we have had. It's a hybrid architecture. So you have a highly available hosted service. This is much like what Ian described. It manages all of the task executions, right? So you submit to that. It's a fire and forget model. So you're able to submit and walk away, and it manages all of the execution that happens. Any system that you want to integrate into this, you run a compute agent. It essentially uses Parcel. The compute agent actually uses Parcel library, which many of you may be aware of. It's quite widely used in the research space. And that provides abstraction to the various different types of compute systems. So whether you're running a particular kind of scheduler or you're talking to a different type of compute system, that provides all the right abstractions there for there. And right now, for you to be able to submit a job and manage your tasks there, an SDK is provided, Python SDK, very much like the Globus SDK, and that's what you would use to submit and interact with the system. And critically, security piece, very much similar to the model that we have on the Globus Connect personal side, right? It uses Globus Auth. It uses layered security. So you have security that is set up on the cloud hosted service, but you also have local controls And ultimately, the local account is used for submission and management itself. Right? So very, very similar models in terms of the architecture and such. We also very recently added a web interface. This is the beginning of the web interface to compute. Right now, it's more of an information interface. You can come and see all your endpoints, that compute endpoints that you have deployed, and also see details about each of those, the status of the endpoints and some submission information. But this is just the beginning of this. As we have learned over and over again, reducing the barrier to entry by adding web interfaces really does help users, and we see dramatic growth. So that's certainly what is planned on the compute side, right? So we expect this to evolve rapidly in terms of adding new features. One of the things the team is working on right now is multi-user compute endpoint. So if you tried compute today, you would use it in a mode where it's a personal endpoint. So you run it, you're the only one who can submit to it, you're the only one who can use it, very much like Globus Connect Personal, right? What we are working on right now is a multi-user endpoint that essentially allows an administrator to stand up a compute endpoint and set up policies to allow their users of the cluster to be able to come in and access it. It will use very similar security principles as Globus Connect Server does. So you'll be able to configure domains that are allowed, have mapping to local accounts, and all of those. So that's being actively worked on right now, and that's probably the first primary deliverable on this one. We're also looking at integrating transfer for staging and data out. And then, like I said, expanding the web interface, right? Both for users, but also importantly for administrators. So once we have the multi-user endpoint, administrators being able to come and manage that deployment, much like they do their data side, is something that you will see more work on over this next year. Yeah. So that rounds out our various pieces of the platform, very little of highlights of what has happened in the last year and a little bit of where we're going with it. So I want to sort of talk a little bit more on product strategy drivers. So what are the big things that we are looking at? What is driving roadmap and where we are investing, right? There are sort of mainly four thrust areas, and I want to go through them a little bit, and then I have some information on sustainability before I close out. So the first one is the holy grail of the research world, essentially reproducible research, right? For as long as I've worked in the space, we have talked about this and thought about how to make this possible. And it remains a big focus area for our community right now, especially with mandates coming in from funding agencies and such. We've had several conversations with a lot of the Globus customers about how Globus can play a role in this and how we could make it easier for you to use this, right? I want to take a few minutes to talk through that question of how Globus could be used here and where we see our role here. And I see this as a spectrum. There are various ways different parts of our platform can plug in. We can go from a turnkey solution to using different parts of the platform, right? So in some cases, you're lucky enough to have a domain repository that you're able to deposit your data. It has domain-specific search. It supports metadata that is relevant to your scientific domain and such. And they are also providing storage, or maybe they're using storage from where you have it, pointers to the data there, right? So in those cases, they often are using some persistent identifier service to be able to provide a DOI for your data, a digital object identifier, right? So I have a couple of examples here. DataSite is commonly used. If you're part of DOE, OSTI has a service as well, and so on. We certainly see the data access piece playing a role here, right? We are having conversations, and we have seen integrations where they are plugging in Globus transfer and sharing capabilities to be able to support the scale of data that they need to support on these domain repositories, right? So that's one piece. The other interesting piece is also flows. How does data get in here? What the publication steps itself, the curation steps, and so on, right? So using flows to be able to automate all of those pieces and streamline those pieces is another part of this equation. So even if you have a domain repository you're working with, or you're able to put data in, these are some ways we see that being enhanced for supporting the volume of data and the scale of data that needs to get supported, right? The second one is the more general repositories, right? NIH has a whole effort around this generalist repository. And then in some cases, institutional repository. We recently learned Stanford institutional repository has been looking at how to support large amounts of data on their current software stack, right? And I think you'll also hear from Dataverse later today, which is one of the generalist repositories in the NIH effort. So in this case, again, everything I talked about in the previous one, using transfer and sharing, which is what Stanford has done. They've taken their institutional repository and added Globus transfer and sharing support so they can allow people to deposit large amounts of data and get the data out as well. But also flows, being able to use flows for automating these tasks. And I also added search in here because it is interesting. The generalist repositories sometimes do not have the ability to take additional metadata. So the metadata is the general, the publisher, title, author metadata. So you can certainly stand up your own search index, which has a more domain-specific metadata and search, and cross-reference that, right? And there are several, for example, MDF is such a repository that we have using Globus. Materials Data Facility uses the Globus search, and it has domain-specific metadata in there as well. And then the last case is where we get requests. We have storage. I need to publish. What do I do, right? Does Globus have a turnkey solution for being able to publish those pieces, right? And there, you could build out the capabilities that you need. So you could, for example, our global portal framework, the Django portal framework that we have, has all of these pieces. It can plug into a storage system that is Globus enabled. You can point it at a search index. You can define the metadata that you need and stand up an interface for people to be able to come and find your data. Okay? Of course, I'm not advocating that everybody stand up their own tiny search indices and partition this data to death. But there are, if you're looking at setting up a community repository or building some of these things out, these are ways that you can plug in with Globus, right? We see this as a significant area of investment. We are having discussions with several libraries, lots of campuses who are thinking about how they support their researchers in making the data available. And some of the areas I see where investment will come, pre-built flows for publication. Globus could be providing some of that. Action providers allows us to reach out to external services. So if you already have a persistent identifier service that you're talking to, being able to integrate with that. If you have metadata extraction services that we can integrate with. Portal frameworks, like I talked about, is another area. We're also looking at how we can do even simpler single-page applications, right? User interfaces for these things. Then the last point I want to mention here is beyond data, right? What about the tools, being able to actually publish potentially the code that was done, so talking about containers and being able to publish those as well, and how do we facilitate that from within the platform? So these are all interesting areas for us. We continue to think about how we can make it simpler, easier, and what kinds of not just platform capabilities, but also vertical solutions that we could potentially build in this space, right? The second thrust area is thinking about institution-wide deployment. So you saw two examples when Ian showed you one, and then the UCSD one I showed you, and a lot of the institutions here have several places where Globus is deployed, and they're also interacting with several different departments themselves, right? So you have instrument facilities engaged, you have the central compute, sometimes enterprise computing also in the mix, especially when you think about things like Box and Dropbox coming into the play. So it's no more just sort of a research computing storage-centric view of this. We are starting to get lots of different parties within campus coming together to provide the researchers a more comprehensive solution, right? So now Globus has a lot more pieces here as well. So you have all these storage collections, you have endpoints on the compute side, flows and runs, and we are starting to look at how we can provide managers or administrators at institutions a more comprehensive way of managing all of this, right? And one good example I can provide here is just even policy definition and management, right? So if you want to set policies around how these things can be used, how can it apply across the board? Another really good one that we have had interesting discussions with is about capacity management. So capacity and limit management. So let's say you have an instrument facility that you know is going to start a big run, and you want to be able to ensure that they can run as many transfers as they need for that period of time, or they have the capacity to run extra flows. Being able to empower the institution to make those decisions, and within the limits that are placed, being able to manage their own capacity, providing potentially dedicated capacity for those. And then more tactical things like dashboards. I think we've already asked, someone has come and asked us, how can I see all the flows that are running in my institution, right? You're used to seeing all the transfers and people are looking for that. So even just being able to provide that kind of a view and management capabilities. So what are some places there? I see this as this is very much, I'm focusing this from an administrator perspective or somebody who's managing this, but even from a user perspective, they end up having so many different entities within Globus that they are handling, and how do we make it easier for them to manage that, right? The third one builds a little bit on Ian's statement on integrated research infrastructure. So essentially streamlining what you can do cross-facility, right? I know the IRI, the integrated research infrastructure, is a phrase that is used within Department of Energy and their efforts there. But really what the goal there is to be able to support a researcher who is trying to use resources across different institutions with different security policies and different types of resources. And I would argue that's pretty much the premise of why Globus was started. From the very beginning, the idea of geographically distributed resources and what we've done. And hopefully, a lot of the features that you have heard from us, the capabilities, you can see that it is pretty much built ground up with that idea of working across these things, right? But there are some additional challenges that come when you go cross-institutional, especially when it comes to facilities. Thinking about bridging IAM, we have a lot more OAuth services out there. Everybody building their own token services. How do we bridge across those? Identity and attribute assurances. So if University of Chicago says I'm a staff, is it worth it when I go to APS to access data there? How do we provide those assurances? And then again, providing some integrations. There are a lot of facilities with their own APIs and programmatic interfaces for accessing and managing, but using flows as the way for a user to interact with all of those. So the user is not learning these different methods, but rather being able to build a flow and use that as the way that they interact across all of those, right? So that's a place. And we see on-demand computing come right along with that, with Globus Compute and the family of services that we have, portable computing and being able to move it to the most suitable compute is going to be a big part of this as well. Then the last one I'll talk about here is going back to sort of this applications theme, right? We all see the amount of investment that is happening in our space with research software engineers and applications that are built, customization that is happening, and being able to provide a platform for them to build their custom application is a big thrust area for us, right? So it's a very product block diagram, but the point I was trying to make put across here is all of these services very much are layered on, and we have very well-defined interfaces for you to plug in resources on one end, whether it's Globus Connect or the compute agent or action provider interfaces for you to bring external services. And then on the other side, we have open APIs. So investments, whether it's adding more pre-built flows that automatically integrates, or additional investments in the action provider framework. So people who are building APIs can provide the plugins for Globus flows for people to leverage that. SDKs, we have the Python one. We've started working on a JavaScript SDK as well. So we hope to get that out there, including some UX components. So making it easier for you to build and plug into this infrastructure. And a lot more in terms of integration with portals and providing essentially the tools to make it easier for you to build on our platform, as opposed to having to just use the platform writ large, right? So I see this is a slight shift in a user base. So it's not just the end users who come in using the web application or the administrators who are thinking more about deployments, but it's also people who are developing against it. They've always been an audience for us. We've always kept that as a focus, but I see sort of a need for increased investment there over this next few years, right? Okay, to the last section of this is probably the most important section. We put it at the end every year. We should move this up next year. So we wouldn't be able to do this without being able to sustain our team and our operations. So as it was mentioned earlier, we are a team within the University of Chicago, and the subscription-based model is what sustains the Globus operations. We do apply and get grant money, but it's for mostly new product or new areas of investment. For example, FunkX is a great, when we were doing something new that was funded by it, and then we use the subscription model as the way to sustain all of this, right? So large majority of our subscribers, academic institutions, national labs, and we have subscribers both here in the US and worldwide, Europe, Australia, and quite a bit. This year, we wanted to talk a little bit about a little bit of shift in the landscape, subscription landscape, right? The largest bucket of our subscribers are universities and national facilities, right? National labs. Again, whether it's national or whether it's in the US or international, that still remains the big one. And we've had a slow growth in independent research institutes and healthcare systems. So since our introduction of the HIPAA tier, we've had more healthcare systems come on board. So this is just one fiscal year data. In the one fiscal year, the past year, we have seen a shift here, right? We've sort of seen an increase in the number of independent research institutes and hospital systems that are subscribing to Globus, a percentage increase, and a little bit of slow growth in the academic institutions and national facilities as well. So again, 1 year data, but this is interesting. This is an investment we have been making as well. We have been working with a lot of the independent research institutes. They have very similar needs to campuses and academic institutions. A lot of them end up working with campuses as well. So there's been a lot of focus and engagement with them. And the healthcare systems, definitely the security and the compliance piece has been the big shift there. Spending a lot more time trying to get contracts that are at the high assurance and the BAA level with these systems. And then from a product perspective, growth areas for us, premium connectors by far. I mean, this is where you see us investing in things like Dropbox, right? Driven by various reasons, there has been the chase for cheapest storage that has gone through many vendors. We had big uptick in Google Drive, first Box, then everybody went to Google Drive, and now they're looking for the next one. A lot of people have moved to OneDrive now because of their enterprise relationship. But overall, we are definitely seeing more connectors being added and used. And then similarly, protected data management, because this follows from my previous slide with more hospital systems coming into the fray. We're definitely seeing an uptick in the number of BA in this, right? So I definitely want to thank all our subscribers here. So for those of you who are new to Globus, it's a freemium service. We still have significant usage of Globus, of free users as well. So a lot of the transfer functionality I talked about is free, but we also see a sustained growth in subscribers, which is fantastic, and that helps us add all these features and continue to deliver value for the community as well, right? And I also want to thank the funders. A lot of the seed funding for the new capabilities came from a lot of the different funding agencies listed here. So that's another facet as well. And our professional services team continues to work with a lot of grants where they are part of other grants and they get funded to build the verticals on top of the Globus platform as well.